my notes on my tablet, but that's I don't have right now. But hopefully, I still can kind of justify whatever I have read in this particular chapter. Here with chapter 10, which is identity, which is very important because you would need to know who's kind of come in accessing the applications, or for example, if you are serving something, they'll connect, like user or workloads would connect to you. So we should be able to know that who connects, right? So we know that in Kubernetes we have authentication, authorization. So authentication is how do you identify a given user, like who can log in, and then authorization is what somebody can do. So I think we talked about authorization some time back. Authentication is something who can log in, or how to identify a given user. That is something which is part of this particular book chapter. Sorry, yeah. So there are different ways. Let me just quickly glance through. Okay. Of course, for authorization, we would be using RBAC, which is going to help us for a given user what somebody can do. That is the RBAC part. But here we will talk about primary authentication part. That is this particular chapter is all about. Um, there are few properties what has been mentioned here. It needs to be verifiable, which means when a user enters the username and the password, we should be able to verify that this is the given user. And that we can do, of course, by checking with the username and the password, or if we can verify the certificate what has been provided. So by that, we can verify the given user. And then it has to be unique. So you can't have a single or multiple user having the same username. That's going to be that should not be the case when you authenticate a given user. Um, so of course, authentication is a very important. On after that only we go to authorization. So authentication is the must part there. Um, Actually, just give me a minute. I'll get my notes. Yeah, sorry, just because I may have to just go and random otherwise. Yeah, just give me a minute. iPad charging नहीं है नहीं iPad Sorry, guys. So we still need to wait for a few more minutes. Can we just get started up? Okay. Okay. By the time it is happening, as we know that, right, in the Kubernetes ecosystem, we don't have inbuilt resource like pod for a user, right? So Kubernetes does not create object called user for you, and it is good because there are already different ways by which we can authenticate our users. So for example, every company is going to have some kind of single sign-on and so on stuff there, right? It doesn't make sense to kind of have another layer on top of Kubernetes to make another user, correct? So that is why it has not been built intentionally, maybe, that when there are ways by which we can do it. Why to kind of add another layer of authentication on top of Kubernetes, right? So that's something which is a thought has gone through, I believe, before this. So yeah, I got my notes. Just a minute. Yeah, cool. Okay, great. So these are identity correct part here. Okay. Yeah, we talked about this already. That OIDC. So yeah, so the point was same, right? That we can do this thing by different means, and OIDC, which is like a single sign-on, which is already can be configured. Then why not utilize that for the Kubernetes there as well? Now there are different ways by which authentication can be done. One of the way which was mentioned here is the shared secret, where basically we yeah, so basically in this case, typically what can happen in the Kubernetes way that we can have the a file which we can configure. So for example, when you are configuring your API server, what we can do is we can create a configuration file which contains the user names and tokens which can be given to the API server. And when somebody logs in, we can kind of look at that particular configuration file. And if the user exists in that, then the user can log in into our cluster. So has anybody configured this kind of settings in which you are passing the mapped file in a CSV file like username, password, and your um, password token and give it to the API server? Anybody has done that? I remember in the GK configuration earlier, this used to be a way where you get the basic authentication method, and in that, this was one of the way by which you can log into the Kubernetes cluster. So, what do you think? Was it going to be a good way or not a good way of authenticating the users by giving this static file? Anyone has any comments?
I mean, having a static file always and then updating it and keeping it updated with the users who have left and who are still remaining, and things like that are kind of complicated. So I would go with the no. It would not be a very good practice, I guess.
Yeah, of course, that is going to be a challenge, and of course, one of the other way to look at is, um, yeah. So of course, when somebody leaves the organization, you need to, of course, remove that. That is one of it, um, and generally they don't have any expiration date, right? So you are not kind of deciding when this particular user would become basically invalid in a way, right? Because once the config file is being given, it is there. Then other thing is that when you change the configuration file, the API server need to be restarted somehow, right? And that can be another challenge because as you're going to add new user, it is going to be an issue. So what happens if you have done it earlier or not? So there is um, you can create a regular file in which you can define username, passwords, and there, and then you can pass a parameter with some hyphen password file. I don't know what it is to the API server, and then you give the location of your configuration file, which or that text file what you have somewhere in your environment. And when somebody logs in, the API server is going to look that file and then check out the or verify that and then let the user get it. Correct. And we saw the challenges what can be there. All of these challenges can be there, which we just mentioned right now. Hope that makes sense. The other way of kind of going it further is rather than having these information in a file, uh, we can go with the public key infrastructure. What does that mean? Is it's a PKI model, which is public key infrastructure model. What does it mean is we are going to define. You're going to have public and the private key for the user, and then you generate a signing request for a given user, and then get certificate from the CA. Now let me demystify a bit to make it much more simpler. If it kind of looking challenging here. So the way it works in a similar principle, the way we kind of access any HTTPS based website, right? So we know that, right? If I open a bank website, I know that I get this green whatever lock on my browser, right? And it tells me that okay, this particular site is verified, correct? So what is happening here is you as a or the browser, right? When it's kind of trying to access a website which has not been opened earlier, and so what happens? That site presents a certificate to you, and you can verify by some means, correct? And if I can do that, I'm perfectly fine. If I can verify, the browser can verify that okay, this site is legitimate. I can continue the transaction on the site. The same thing is going to happen with the case of the user, right? So when a user is going to log in to the Kubernetes cluster, it can provide certificate to the API server. And if the API server can verify that, okay, the certificate is valid, it can allow the user to log in, correct? So maybe let me ask a question. Have you guys done this kind of CSR creation manually and then have it verified by the CA? Have you guys done that part earlier? Anyone has tried it? I know Benjamin would have done it for sure. Anybody? Sorry, Abdul?
Yeah, I mean, for SSL certificates, we've had to do it.
Yeah, for Kubernetes, I'm asking specifically.
Not particularly for Kubernetes. Certman
Okay,
is the way.
set man. No, so that is for the website, correct?
Mm.
But what about for the users, right? Um, have you done for the user?
No.
No? Okay, fine. Okay, so let me just kind of take a bit slow and then try to cover that particular part here because it is one of the important part. And let me just see if I can quickly because I remember I did this earlier. Just give me a minute. I'll try to get the lab for that. Important concept to kind of understand. If I can show you by some means, I'll try to do that. Uh, okay, I can do that. Let me just quickly try to get that lab here with me. Yeah, I'm just going to get that so that let me just reshare my screen. Sorry to kind of share.
Not yet. Not yet. I
Sorry.
don't think we can see. I don't think we can see a screen yet.
Now you can see, right? Correct. Yeah.
Oh, okay, it's coming up now.
Yeah, correct. So yeah, quickly, I'll just tell you what's going to happen here, and then we'll kind of look at the flow of it. Um, So what happens first of all is when we have a Kubernetes cluster, it by default creates its own CA, right? Uh, which is certificate authority it can create, right? Through which we can create certificates, right? So as we configure Kubernetes cluster, we have our own CA already as a part of the cluster. That is the point number one. Now, when we want to create a user, right, or we are creating a user to which you want to allow login to the Kubernetes cluster, what we can do is we can create a private key for it, and of course, public key can we can kind of get it from there. Now, what we'll do next is we are going to take that public key of that given user and generate something called as signing request. Now that signing request, currently we are using the tool of OpenSSL, but then we can convert that particular request into a Kubernetes object, which is certificate signing request. And then we can give that signing request to our Kubernetes CA. And then Kubernetes CA can basically verify, or basically we can then authorize by the Kubernetes CA to generate certificate for that user. So for every user, we generate certificate. Now, what's going to happen for the given user? We are going to have the certificate and the private key. So if you have noticed in your kubeconfig file, which I believe you would have seen, that you have this client certificate data and client key data, correct? That is visible as well, right? Yeah, right? So now this particular information for a given user, right? So when I as a user, so if you have seen your kubeconfig file, in that kubeconfig file, you can see for a given user, you can provide the certificate data and the private key. Now, when you run this kubectl get pods or whatever the commands are there, right? This particular information sent to the API server, so we send the certificate to the API server, and then the API server can verify, yes, this person I have certified by some means, right? And then I can allow that user to log into my cluster. Correct? Hope that makes sense. Any questions here? Okay, so I'll not go through the entire lab, like run it, but I'm just telling you kind of how things are happening here. So what this particular lab which we have built earlier, in this particular, what we have is we are creating a CY-user key. So we are generating the private key. So the process is same. I'm generating a private key through which we can create a signing request. So I'm creating a signing request. And as you can see, the important part here is this CN. That is also mentioned in the book as well, that how would you identify a given user? So once you have a certificate data, right, and if you look at the data details, right, you can find out the information from it. So there are commands through which we can identify some information, like as you can see here, this CN, which is a common name. So we know that there is nothing called user in the Kubernetes object per se, but as you log in, how do you identify for which user it is, right? Certificate is valid per se, that's true. But when we configure our RBAC policies and so on, we have to somehow say which user it is. And that is done with the help of this common name. So if we have any certificate data, and if you run this open SSL command, which is I think somewhere here. And if you look at the data, if you kind of unpack it, it comes like this, right? So this common name is a very important piece here, that what is the username? And that is what you can see here when I'm generating for a given user. So what I'm showing you here, that is happening behind the scene for the Kubernetes-admin user behind the scene, correct? So as we done the kubeadm init command, these things are going to happen. So assuming that our user is CY-user, now for this user, what we have done is we have generated a private key. Now, currently this user is not part of my cluster at all. It is sitting somewhere else, right? I'm just on my laptop, run this command in a way, right? And then I generate the signing request. And in the signing request, I'm saying that this is for the username called CY-user, and for the group called cloud user, right? And then if I look at this data, it will going to come something like this, which I think mentioned here somewhere. Yeah, like this, right? So if you look at this particular request here, it is going to come like this. So this is the same thing what is being mentioned here. So you have, if you run this command, OpenSL, this option, and then you give the CSR request. And look at the text here, it's going to come like this, where this common name is John in this particular case because we have given it here. Now, once we have this particular signing request, which we have done, what we can do is we are going to convert this particular request into a Kubernetes object, which you can see here. We are doing it with the help of kind or object type certificate signing request. So we are going to generate a signing request in the Kubernetes terms, and then that request would then be in the pending state. So I can first go and create the signing request, give it to Kubernetes cluster, and then this requester can be non-admin user as well. So currently, because I'm the admin, I'm putting a request. It is going in the pending state, but it can be requested by somebody else as well who has the permission to create this CSR request. And then as an admin, I would then basically approve the request. So now once I make it approved, what happens is a certificate gets generated. That's the thing what we discussed here, that once the request been approved by the Kubernetes CA, I'll get certificate. And once I get it, what is happening is for that user, I have the private key already and I have certificate. Now this can go in my kubeconfig file, and from there the conversation starts, or the discussion, or basically you can say that it starts talking to my Kubernetes cluster. Does that make sense, guys? I know this kind of maybe a bit tricky to get, but hopefully you have got it. If not, then please let me know. I'm just trying to see if I can get a local K-test cluster right now. Guys, any suggestions, any comments on this? How do you start? Generally, I don't use the local clusters. Okay, fine. I'll let it come maybe. Does that make sense? Benjamin, anything you want to add here?
No, that sounds good. If you have a demo, that would be awesome, I think. I don't know if you do, but
Yeah, we can do that demo, not a problem at all. Let me.
I know it's a long process usually. Like you'll probably have to run 10 or 12 commands or so.
Let's see. We try to quickly do it. That would be actually worth doing demo, because this demo generally we don't see it. So let's just check if my cluster comes up either here or on my lab environment there. I should have made it ready. Give a terminal up. Yeah, it is running. So cool. We can actually do that demo now. So what I'll be doing is I'm going to create a namespace here. I just create a namespace. And then what we're doing is we are going to use this OpenSL tool to generate. So let me just create a demo. Let me just do that. Okay. So now in this particular folder, right, I have generated this particular private key that is there. Now from this particular key, what we'll be using is we are going to take out the public key from it and then generate something called as signing request. I'm just going to copy this command here. Now what is happening here is I am taking this particular key which I have in the last step. And if you want to look at, I just do this CY user key. You can see it's a private key. And now with this private key, I'm going to run the next command to generate a signing request. So as you can see here, I'm generating this signing request. So here now I have got this CSR file, right? And this is there. And now we can run that command which was mentioned in that book, OpenSL command, and then try to decipher it a bit. So let's see. It was here, right? Yeah. So now I'm going to change the name of it. So you can see here, this is being kind of unpacked. And you can see here, it is the certificate request. As you can see, it's not a certificate, it's a request or certificate. And it is for the user called CY-user and for the group of Cloudilla, correct? So that's the request I have kind of generated. Now, once that has been done, next part is I'm going to basically do the encoding of it into base 64. So I'm just going to do that here in my setup. So as you can see, I've got this data. What I can do is I can dump this data into a file. Let's say something csr.txt, whatever. I just dump it to a file. And then what we'll do is next is we are going to have this signing request, right? So I'm going to create this signing request file because now I want to send this request to the Kubernetes cluster. So currently these are nothing but a typical OpenSSL based files. But now I want to convert into a Kubernetes object, right? So I create the signing request file and then I'm going to copy the content, whatever is mentioned here. We can go over it. So what we are doing here is currently this request field is empty. So what we are doing is we are creating a signing request, right? And then for the client auth purpose. So I can basically quickly read that file. You can see I have just got this data, the request file. So I'm going to create a Kubernetes object from it, correct? Why this is not coming? This should be part of the thing as well, right? Why that did not get added? I don't know what happened, but there should be a percentage sign also at the end. Quickly add that. Yeah. So once we have got this object created, not object, just a YML file. So I'm just going to apply the file now. So okay, then I think it was fine. That sign was not required actually. I was kind of over smart in that case. Maybe something in the terminal. Okay, anyway. So as you can see here, the signing request is now being created. So I am Kubernetes admin user, correct? Because currently I ran that command, right, to create the object, right? And that is why if I look at kubectl get CSR, which is signing request, you can see here, it is saying in the pending state. And who requested that is the Docker for desktop user currently, whatever is there right now in this kubeconfig file. That's perfectly fine, right? Now, what we can do is we can now approve this request. So currently, if I try to look at this data, let me do that. So if I do get CSR, this file and do -oyaml. So you can see here in this particular signing request, um, the request is being sent for sure, and there should be a certificate section which is should be empty now. So client dot spec. Okay, maybe it would be added after we have done the authorization of that. So now what I'll do is, because I am also an admin, I can now approve this request. So what I'll do is, I'm going to say kubectl approve CSR and the given the request what I have, right? So you can see here, certificate approved, sorry, I think so. Sorry, certificate. Yeah, so you can see here, it has now approved. Okay, so I think this name was not, this, the first CSR should not be given, but that's okay, you can ignore that. You can see here, our CSR request, which was cy-user-CSR, is now approved. And now if I look at the get CSR, you can see here, it would be now in the approved and issued state, correct? What does that mean is, now if I try to look at that particular same YML file of the CSR, you can see here, there would be a certificate data status, right? Which was earlier empty, as you would have seen. But you can see now the status, we get certificate as a back, correct? So now for this user, what I have right now, cy-user, I have my private key and I have the certificate, but it is part of the CSR. So what I'll do is, I'll take out the certificate and put it into a file or convert into or use it as it is, the way it is right now here. Okay, so what we do next is, as a step, we are going to copy it into a file. So what I'll do next step is, I'm just going to get this data from here. So what I'm doing the next step is, I'm saying that just read the certificate data and put into a file called cy-user.crt, which is not there right now, but it would be created right step right now here. So as you can see here, I would have got this particular file with me now. So I have a private key and I have certificate which is verified or created by my Kubernetes CA, correct? So now for the CY user, now I can log into the Kubernetes cluster, but after, of course, updating our kubeconfig file. Hope everybody is following so far. Make sense? Guys, nod, yes, no, something.
Clear. Yeah, please. Very interesting also.
Okay, great. So now what we do next is, we are going to create our kubeconfig file. And in the kubeconfig file, we need to add that for this given user, I want to set this given CRT file and the key file, right? So I'm just going to copy this particular command here, paste it here. And now what is going to happen is, it is going to create a configuration in my kubeconfig file. So if I look at .kube config, you can see here, yeah, so you can see here under the section of users, we have got a new section for the cy-user, which would have been not there earlier for sure, right? So, so what we are saying for the CY user, this is the location for the certificate data, and this is the location for the private key. Hope it makes sense, correct? And of course, you can always dump the base64 encoding as it is as well. So we can either give the location of a file, or we can just dump it, the base64 encoding here. Both works actually, right? So in this case, we are giving the file location, that where our certificate data and the key file is. Okay, make sense? Cool. So the next step now is, we have to update the context. So as you know that, right, in a kubeconfig file, if I look at kubectl config view, You can see here in the kubeconfig files, what we have is we have a section of clusters. We have section of clusters in which we define multiple clusters. Then we have section of users in which we define multiple users. And then we have the context, right? In the context, we connect a user to a cluster. That is called context, right? So here, as you can see, we have two clusters running here. One I have with Kind Educates, that's one cluster. And second is Docker Desktop, to which we are connected right now. But currently we don't have, so as you can see, the context is here for the Docker Desktop, for the user Docker Desktop here. So as you can see here, we have Docker Desktop user and Docker Desktop cluster. So we have a context for it. But now what I want is, I want this CY user to connect to my Docker desktop cluster. So I'll generate a context here. And in that context, I'm going to map that, I'm going to create mapping saying that, hey, CY user can connect to a given cluster. So I'm putting that mapping here. So for that, I'm going to quickly get the command here. Now what I'll be doing change here is, I am going to change the cluster name, because the cluster name for me is Docker-desktop, not Kubernetes here. So once I do this, Docker desktop. Now you can see here, if I do a config view now, you can see here, I have got one more context here, correct? This context is saying that this context with the name of CY-user context. So in which I'm saying that you have the user called CY user, connect to the cluster called Docker desktop, and for the namespace called cloud user, correct? So now I can say that use this particular context to log into my Docker desktop cluster, right? So let's do that. So if I do kubectl get context, I think that's the command. Now while let me get the command from here. Okay, so what is that command? kubectl
Config, I guess.
Yeah, I think, yeah. Config. I want to get, okay, let's just get.
Yeah.
Yeah, that's the one.
It's like a with a dash. Get
Yeah, that's correct. Yeah, correct. Yeah. So if you look at here, I have three contexts available in my cluster, right? And the star sign means which is active. So of course, at this point of time, I can do namespaces and pods, whatever, right? But now I want to log in as a CY user. So I will change the context, right? So I can change the context at runtime, like the way which is the example which was given earlier, which I was kind of having it here. So like in this case now I'm saying this particular change, this is going to happen only for a time being, right? So for example, now I'm saying that run the command of kubectl, right? And with the context of CY user context. So now just raise your hands raise your hands if you can think that I can list the pods here. Do you think if I run this command, would I be able to list the pods? As you can see, we cannot, right? So what happened here is, it is saying that pods is forbidden. User CY-user cannot list the resource called pods. What does it mean? That authentication succeeded, right? Because the CY user can log into the cluster, but this user does not have the permission to list the pods. Does it make sense? So what happened here is the CY-user can log into the cluster, but it cannot perform the operations because it does not have the right RBAC policy. That is what this particular thing signifies. Are you following me? Yeah. And of course, if I set the use context, then I can change the permanent setting as well if that is there. If I do this, I think I don't require the config command in this case, or use context. Yeah. So now the context is completely by default is set to the CY context, and of course it's going to fail now. The same error I'm going to get here because my user does not have the right permissions. So let's do one thing is while we are here, let's try to look at let's add the RBAC rule as well. And then, but of course I cannot run the RBAC rule as a regular user. So I'll become the admin user for a time being, correct? And then I'll create the RBAC policy. And with that policy, I should be able to list the pods and so on, right? So let's quickly get those things as well. So I'm going to create a role first of all. Right. So now I'm creating a role here. What is the role here? So again, role, as you know, work on a given namespace. I'm saying this role is for the Cloudega namespace. And with this particular role, the user can list the deployments, pods, replica sets, and so on. It can create them as well, but can't delete and other stuff. So I'll not go in RBAC policies here, but I'll just quickly apply this role for time being. So once I have applied the role, so this particular role is applied in the Cloudega namespace. And then I would create the RBAC policy here. Right. So in this case, what I'm saying now is, I'm now saying in the Cloudega namespace, the CY user has the deployment manager role, which means the CY user can create the pods, but can't delete them or can't create services as well, right? So let me just quickly apply this policy as well. Right, this has been done. Now, if I now go back and try to change the context for timing and list the pods, now you can see I'm not going to get an error here because there are no pods. That's why I cannot list them, but I'm not getting any error. Hope that makes sense, right? So I can now create pods here as well. So I can say run nginx -- image is equal to nginx. So you can see now, I can now see the pods, right? Because now my user can both log in and can perform the authorization as well. Make sense, guys? But of course, because we have not given the permission of deletion, so it cannot delete the pod. Right? Because that our user does not have the permission of removing the pods. Right? So as you can see here in the rule, we are just giving the list update and then create, but not delete here. So the user cannot delete the pods. This is how the entire thing works. Correct? Any questions? Or any other points to add here? Okay.
For me,
fine.
the concepts is clear now after
Sorry?
this demo. Thank you. For me, the concepts is now clear for me. Thank you. Thank you.
Okay, great, Ramkumar. Okay. Fine. So this is how you can create the users. Now, can you tell me what can be the problems in this scenario? So of course, we have seen that perfectly fine. I have a user, I can create it and perfect. Now, what challenges you can see in this approach? That's the next part of it. And then we'll go to the next section.
Well, you have to manually go in and revoke permissions for users. So it's not easy to basically manage people that leave the company, I guess. I mean,
Yes.
easy, yes, but like it's tedious.
Yes.
And
of
it's
course-
like you would basically have a copy of users if you already have them potentially in a different system, like AWS or whatever you use, LDAP.
Correct. That's a good point. Yes. So of course, there's a thing because if somebody leaves the company and if the certificate is valid, right? If they have the certificate and they can access the cluster, they can come and log into the cluster, right? So unless you go and revoke the given certificate manually, or of course put some processes there, it's not going to be an easy task, right? So yeah, that's the challenge what we can face in this scenario. Correct. Let me just check. Is there any points to be added? And that was, if I kind of go back to the image here, right? So you can, that's what mentioned here. This is how the entire process would work. So this is what we already discussed, right? CSR, approve and all that. I think it's become clear now, right? If you have any questions, you can still reach out, not a problem.
Yeah, I have a question. So, just like a basic one, when I want to revoke a certificate, how do I do that? So, I have a CSR, I got my certificate back, and now I want to revoke that certificate. How do we do that?
Yeah. So, so generally, if we have to revoke, we would need to kind of go, and there would be similar command here which I tried earlier some time back. Let's just see. Of course, I cannot go and change the thing. There would be a command here by which I should be able to change that. I don't have a command handy. I need to get back
But
to
you
you.
mean, but you mean there would be like a kubectl command with which we can just revoke a user certificate?
Um, yeah, that's what I recall actually, because yeah, that's what I recall. That you can. Benjamin, do you have any points on that? We need pointers on that.
Sorry, ask the question again.
The question is how to remove certificate for a given user once it is being given, right? So what command is used for that?
You want to remove it from the kubeconfig file, or?
No, we just want to revoke because certificate is valid, right? So how do we?
I don't know. I gotcha. I don't know it off the top of my head right now.
Yeah, that is. So the certificate is so private key is belongs to the user. Certificate is still having it, right? So I think the only case in this ways, you have to. So you can't revoke a certificate with the kubectl command. What happens in this case is you would have to regenerate a certificate or the CA certificate again. That is what I recall. So there would not be any kubectl command which can just revoke certificate for a given user or make it into a blacklist kind of a thing.
One of the things that I'm reading right now, like while checking it, it says that remove the subject from all RBAC rules is what
Yeah,
is an
correct.
option.
That is one of the way of doing it, but that is
Yeah.
still that is you are removing authorization, you are removing not authentication.
Right.
Correct. So that is a valid point that whatever the RBAC policies you have, in that you remove all the CNs, right? Whatever the username. Correct. But that is not revoking the authentication part. Correct. So the approach of that going to be you need to regenerate certificate um, for your API servers and so on. That is the challenge here. That is, I think, what have been mentioned very clearly here as well. That if somebody leaves, let's just try to take a look here. Yeah, so one way to do it is basically you can keep the certificate expiry timestamp for the less time that can be done. So prior to expiry, yes, that's the point mentioned here, right? So that you don't kind of by default we get these for 1 year time frame, but as we are generating certificates, we can tell that to for a month kind of a thing. but within that month they can't be expired. Basically, they can't be removed per se. They can't be revoked. Or other way to kind of regenerate the entire certificates for your Kubernetes cluster. In that case, your CA is changed. Then there's no way. But you have to generate for remaining users. That's a challenge what you're going to have in this case, which is of course
Yeah,
a very difficult. Yeah,
that won't be feasible, right? Like
yeah, that won't be
you won't
feasible.
be,
Correct.
yeah,
Yeah,
obviously.
correct. So that's a challenge what you have here. But being said that, you can, that's what they mentioned, additional PK needs to be provisioned, supported, maintained. That's a challenging task here, correct? And then what can be done is basically you can kind of maybe put some kind of admission control there, which can check for a given user. If that user is logging in, then you don't allow them to kind of get in. Something like that has to happen, correct? So some of these things can be implemented, but as discussed, that this is not a good approach. A good approach is going to be you have the something called as OIDC, which is we'll talk about in the next session. That how we can have a single authentication mechanism through which we can log in our users. So like LDAP, Google OAuth, and all that stuff, we would configure that. So of course, when you don't have, you can have to live with first, second approach we discussed. Like one is having a config file, and second is having the certificates, right? But you know that what are the challenges can have certificates. So you have to be aware of that. That's all. Yeah, we'll talk about OIDC next time so that it kind of gives you much more insight that how we can do that. Yeah. So that in that case, we have a single authentication mechanism. Everybody logs in there, and then they kind of uh, certainly manage them. So I think we all use login via Google kind of a feature, right? Same thing can be done for the cluster as well. And then of course, if the user is removed from the LDAP or single sign-on, whatever you have, the user cannot log in. As simple as that. Yeah, that is how it is going to work out. Okay, so I think that's it for today. I hope it was useful. So we don't have session next week, which is Jan 28th. I don't know whether the calendar invite is there or not. Even if it is there, I'll just remove them right now. We're going to meet on the first week of Jan, which is going to be on 4th of January, right? That's the day we are going to meet again. Okay. Hope that is good. Okay, let me unshare my screen.